assignment question for circular motion, question 1. Right? You have a ball that's in a metal ring and it's rotating. So now I draw the free body diagram of small bead, actually, of the small bead, right? Now this small bead has a mg and then a normal reaction force. Now below I draw the diagram, right? The normal reaction force is actually by the vertical loop on the small bead, okay, and this n is the force n will be 90 degrees to the tangent, right? Now this is the free body diagram and it's 60 degrees to the vertical line, okay. Now one thing that a lot of people misunderstood, or they missed out, not misunderstood. Now they got it wrong. If you look at the rotation of the small bead, it's actually in a horizontal, rotating in the horizontal axis, right? So it's rotating, you know, up and down in the horizontal axis. So the radius of rotation would not be r, but r prime. So if when you were to use the equations, the radius you should be using should not be 0.2 meter. 20 cm, right? I converted to SI unit, 0.2 meter. It should be r prime 0.2 sine 60 degrees. 0.2, this is 0.2, right? 0.2 meter. Sine 60 degrees is r prime. Okay, so now having said that, let's start. Now let's solve our equations. Okay, the first equation will be looking at this free body diagram. Now n cosine 60 degree will be equal to mg, right? Okay, since bead is in circular motion, okay, right? If I say this is my y direction, this is my x direction, right? Now summation of forces in the y direction should be equal to 0, right? If the bead is in circular motion, which is this, right? And if I summation of forces in the x direction, okay, that should be equal to m omega square r. I'm not using mv square divided by r over here because they're asking for angular frequency. Okay, angular velocity, right? Angular velocity. So I use this version, okay? That would mean n sine 60 degree equal to m omega square r. Okay, now if this is my equation 2 and this is my equation 1, okay, I do 1 divided by 2, okay, I should get tangent 60 degree, right, is equal to omega square r over g, right? Therefore tangent 60 degree g divided by r root should be equal to by omega. Okay, now this is where a lot of people get it wrong. R, they use this, but it should be r prime. Okay, this radius is actually r prime in this question, so it should be equal to g sine theta over cosine theta. Okay, I'm going to expand tangent 60 degree into sine and cosine. Okay, you divide by r, right? So this r is actually r prime, right? So you multiply by 1 over 0.2 sine 60 degree root. Okay, now these two will cancel out. Okay, it should give you g over 0.2 cosine 60 degree root, right? Okay, now since cosine 60 degree is half, then you'll be 0.1, then you become 10g. Alright, you actually become 10 times 0.81 root. That's it. Okay, the answer should be 9.9 radian per second. Okay, now this part A. Part B is simple, right? Part B. Okay, find the frequency, right? Omega is 2 pi f. Okay, frequency will be able to omega over 2 pi, right? So 9.9 divides by 2 pi. The answer would be 1.58 hertz. In part C, now they ask you whether this beat can go all the way up. Now if it goes all the way up, right, wouldn't the free body diagram look like this? This is your normal reaction force and 90 degrees, right? It is not possible. Okay, it is not possible because you cannot maintain the vertical equilibrium, right? There is no vertical force to balance mg, right? And that's basically the reason. To balance mg, thus vertically the ball will have an acceleration of g downwards. So it can't stay there, right? So that's the answer.